All right, hello and welcome. This video is going to help you get started making your text-based adventure game. It's not going to be a exact tutorial on how to make every portion of your game, but it should help you get started. Now, when you're making your own game, you already have your design diagrams, and it should be distinctively your game. I don't want you just copying the code you see in this video verbatim. If you end up with something too similar, it may affect the design criteria of your score. But you should obviously take lessons and get inspiration from what we're doing here. Now, I'm making a game inspired by my own life. In my family right now, we have three animals: Ada in the top left, Pumpkin in the bottom, and Mr. Reese over here hiding behind the table. Now, despite the fact that they're all orange, they don't really agree on very much, but there is one thing that they can all agree on, and that's that the red dot must die. So I wanted to make a text adventure game that captured this bloodlust of the animals. Now, if you haven't already tried the game that I've posted online, you should go play it now. I'm going to go over the transition diagram for it, and that will have spoilers. If you don't care about spoilers, then feel free to keep watching. Now, this is the transition diagram for the red dot quest, and it's somewhat similar to the transition diagrams that we've seen for our other games, perhaps a bit more complex because we have a more complex game. The flow of the game always starts with the green start node over here, and then begins actually with the player starting in their home. They start in the home location, and then they have the options of going to the surrounding location, so they can go to the nearby forest, or the town, or the winding way. These bidirectional arrows capture the idea of go to X, where X is one of the valid locations: home, town, chapel, castle, so on and so on. There is some sense that the animal's energy must be greater than zero, but as long as that's true, then the locations get updated for the player, and the animal's energy is decremented a little bit. So moving around costs energy in this game. Now, you can at any time nap in order to restore your animal's energy. And you can also, of course, at any time quit. That's a requirement for any game. You don't necessarily need to articulate that on your diagram, but I figured why not be explicit. So at any time I can quit the game. And also, every tick of the game, every round of input, there's a time variable, a time attribute, that's being incremented by 1. And time will affect various things about the world. So the first thing that can be affected by the time is when you're in the nearby forest, during the daytime, you can pick up catnip, and that will set the has catnip Boolean flag to true, the attribute to be true. Daytime is calculated as a function of the current time. If it's modulo, when you take the time modulo 4, if it's 0 or 1, it's morning. So there's a day-night cycle of every 4 ticks. It's another day. 0 and 1 represent the morning and afternoon. 2 and 3 would represent the evening and night. And then it would go to 5, but it actually cycles back to 0 because it's modulo 4. And that allows us to have a recurring day-night cycle where you can only see catnip during the day, and that's when you can pick it. So that's what the time is controlling. The chapel also has something interesting in it. It has an extra command. When you wait patiently in the chapel, you'll gain the ability to be able to bark, and that sets the can bark flag, the can bark attribute, to true. And you can take advantage of both the catnip and the barking in encounters. So there are 3 encounters in the game. There's an encounter in the castle with Pumpkin. There's an encounter with Reese in the wilds, and an encounter with the boss of the game, the red dot, in the Cave of the Dot. An encounter has a different structure than the rest of the game. It has its own little thing going on, and that's why it's in a box off to the right. When you're in an encounter, you have up to 4 commands available to you. At the start of the game, you can only run away or bite. If you learn how to bark, then you can also bark, and if you have the catnip handy, if you have catnip on you, you can befriend the enemy. However, when you befriend the enemy, you lose your catnip. If you run away, similarly, the encounter just ends. And the encounter might end in other ways depending on biting and barking and befriending. So when you encounter Pumpkin, if you bark at him, he will join your party. When you encounter Reese, you have to befriend him, and then he'll join your party. When you encounter the Dot, if you bite it and you have the right friends, then you'll win the game. But if you don't have the right friends, then you'll lose the game. So this is our win-lose criteria. And there are various things that might need to be updated this diagram. I didn't articulate that biting requires you to have all of your friends with you, both Reese and Pumpkin, in order to win. I'd probably need to update this diagram based on the design changes I've made. But this is certainly a relatively complete coverage of the game. I'd also probably have something that explicitly says the winning path and losing path. So winning path being you've got to go to the forest, get the catnip, then go to the chapel and wait patiently, go to Pumpkin and bark at him, then go to the wilds and befriend Reese, and then go to the cave of the Dot, fight the Dot by biting it, and then you win. And the lose path, where you can just go directly to the cave of the Dot and try biting it, and then you lose. So this is the design diagram, the locations for my game. And now we can pop over to my editor, and we can see the template that I've been filling out, the adventure.py template, where I have the classes, the world definitions, already placed into my game. At the top level, I have the world class, where I have 4 attributes. The one everyone is required to have is game status, which is a string, either playing, won, lost, or quit. And then I also have player, which is a player class, so we're also required to have this one. I'll talk about that in just a minute. And I also have 2 other attributes. So I have time, which is an integer, the current time of the game, incremented every tick, and an attribute called encounter, which is a string but can also be none. And whenever we're in an encounter with Pumpkin, Reese, or the red dot, we set this attribute to be equal to the string version of their name. Otherwise, if we're not in an encounter, we just set it to none to indicate that we're not in an encounter. Our player attribute has a player class, so looking at that one, we have 4 attributes in turn. Everyone's required to have the location of their player, which is a string indicating the current location on the map. Then we have 2 Boolean flags, has catnip and can bark, both of which we covered earlier, simple Boolean attributes. And then we have animals, which are a list of animals. This is my custom class. I'm required to have a custom class. I'm also required to have a list, so I'm getting rid of both. Covering both criteria with this attribute. The animals represent Ada, Reese, and Pumpkin. So scrolling down, we can see our animal class. An animal has a name, which is the string, the full name of the animal, and energy, which is a integer indicating the current energy level of the animal. As you move around the world map, the energy decreases as you go. And there are things you can't do when you're out of energy, like move around. So you have to nap every now and then to keep up your energy supplies. Just adds an extra element to the game. So we have now our definitions, and you'll see that we actually have more than the minimum 7 attributes. Now we have 4 plus 2 plus 4, so we end up with 10 attributes. So this is already going to be a fairly complex game. And we have our 3 classes and a diversity of types. We have Boolean, strings, integers, lists, structured types like an animal, and player. So we're doing pretty good on our complexity criteria. So now that we've got all the basics of the design laid out, let's pause here, and we'll pick up in the next video on getting started with the actual project itself.